already said, he is director of the Copernicus Climate Change Service, but that happened relatively recently, and he's been a prominent figure in the domain of climate services internationally for some time now. So just wanted to highlight and emphasize that, and he's been working tirelessly to foster the development of climate services. And he is also a member of the external advisory committee in our project. He's been supporting the project strongly since the beginning. So I'm really grateful and honored to host his keynote talk today. And just please, Carlo, address our online audience, and the rest of the people enjoy his talk. Thanks.
Thank you, Luigi. Thank you very much. Thank you, all the coordination team of MedGold. Is a privilege, I think, to be here with you and to share my view on climate services at this stage in time with all of you. It was very interesting to hear your presentation, so understanding better who you are and where you're coming from. It's just a pity this is not a physical meeting, because when we had the General Assembly last year in Cagliari, it was such a beautiful location, and we all appreciated the local food and wine, and I'm sure you would have done the same. So we have to resort to this online facility, but I mean, MedGold has been experimental from the beginning and has been very successful in this experimentation. So I'm sure that the Living Lab will be another success. So, well, I'm not sure about the prominence. I thank you very much, Luigi, for your kind words. And but it's true that I've been muddling the water around climate services for maybe 15 years or so now. So I've been in the business for some time. So let me just go to the presentation. My idea was to, and apologies for those of you who were at the meeting of the Italian Society for Climate Sciences back in October, because I've reused many of the slides I've used for the presentation there. So I'm thinking about probably Alice. Yes. Is it okay?
Please, yeah. Carlo.
Okay, so I'm thinking of Alessandro or Emanuele, who probably were there, may have seen some of the slides. So first of all, before starting, I thought it was useful to make some caveats, because the presentation today is a bit of a combination of facts. Most of these facts are related to climate services and to the Copernicus Climate Change Service in particular, and my personal views. So I try to make the two, to identify the two as clearly as possible, even visually, but it's not always easy. So just to acknowledge my biases. And there are several mentions to previous programs or previous projects that I happen to have some interaction with, and this is clearly a subset of the whole project, all projects that have been operating in climate services field. And in that sense, I apologize in advance to all those people whose work I miss or omitted in this presentation. I thought it was useful to start with some definition. Alessandro asked me to be provocative and to be disruptive. I'm not sure I'll achieve that with the talk today, but I thought it was useful to start with some point, because probably the first lesson I learned over the last 15 years is that climate data per se is not a climate service. So you need climate data in most, well, basically in every single case, but climate data per se is not a climate service. So climate data, by climate data, I mean numerical values of variables representing the climate. So GCAS refers to ECVs, or essential climate variable, as a way of categorizing this key variable. Then the next step is climate information, which can be obtained from climate data through knowledge, but is not normally sufficient to drive action. And finally, there is climate message, which is the climate information put in the. I was looking back at 2007 and the Ford Assessment Report as a starting point. So I was sort of saying the relationship between us and the climate and goes back millennia, and it's not something that started on a specific day. But if you look at the definition of climate services as we think about it now, I think it makes sense to look back at the early 2000s and possibly the publication of the fourth assessment report of the IPCC as a turning point, because that moment is the moment where there is a widespread realization that there is no longer any significant doubt on the fact that climate is changing and we are largely responsible for it. And the question becomes more, so what? So what do we do with this fact, and what do we do with this information? How this translate into changes in society and so on? And I picked just the two projects that I thought were very important at that stage. One is the Ensemble project, which was an FP6, I believe, project that put together the largest, basically the entire climate community in Europe. A nightmare to manage, but very useful in terms of community building. And the other one was the UKCP, which was the UK climate projection, which probably was one of the first projects to use a very data-intensive probabilistic information about future climate to inform decision. Then in the steps, in the historical steps of climate services, I think the next important step is the establishment of GFCS, so the Global Framework for Climate Services by WMO. And this, again, is linked to the realization that climate knowledge in isolation doesn't drive or inform action. So we need to do more than just providing data. We need to care for the way in which this data is used and how we engage with the users and connect with the communities and so on. There has been around that time a lot of parallel things happening, one of which was the Climate Service Partnership. So there is really, if you want, by the end of the 2010 or thereabout, there is a collective realization that this is a new priority globally and needs to be coordinated, needs to be looked at internationally. And so the Climate Service Partnership was certainly one of those drivers in putting the community together. And intertwining what's happening on the international stage and to the important international program and what's happening on a much smaller scale. I thought this is a nice picture that Alessandro actually passed to me a few days ago. And is around that time, and is around a project that I had the pleasure to coordinate, which was called Euporias, where we were looking at climate services, and many of the people who are here today actually had some engagement or interaction with Euporias at that time. And what you see in the background is a big matrix that we tried to put together, try to ask a number of users who are in the room when specific decisions in the course of a year were taken by different sectors. It was a sort of mapping. So what kind of information is important for you, but not starting from the information or the data we have, but rather starting from the user context. So how do we operate? What keeps you awake at night? What does it really matters to you, and when? Because the focus of the project was mostly about seasonal. So if you want even more historically, I think the first generation of climate services project was even before. So the Clean Run and the Euclides project were just a year and a half, 2 years before the kickoff of Euporias, I believe. And then there was this second generation, Euporias, SPECS, and NACLIM. And these three projects were focusing on different aspects. SPECS was looking at seasonal prediction, NACLIM was looking mostly at oceanographic feature, and Euporias was very much on the service side. And they were asked by the Commission to cooperate or collaborate with one another through a mechanism known as ECOMS. And this led the way to what is Climate Europe. So a coordination of climate services project across Europe that is still running for a few more months, I believe. One of the things that happened during that period was the organization of a workshop, and probably for me this was one of the best workshops I've ever organized. We picked a few people related to climate services. We put them in a nice countryside house in England, fed them well, and for a few days, and asked them to reflect on what were the key ingredients for the development of a successful climate service. And we're talking about. I think Andre was mentioning the importance of storytelling and the IPCC, and we were lucky because we had a visual scriber in the meeting who managed to capture most of the principle we came up with in a nice infographic. And these are the principles. The idea is that if you want the climate service to really be successful, you shouldn't approach it as I have the data, I have the answer, and I feed you, but rather approach, which is never a very good approach, by the way, but rather acknowledge the fact that in a service relationship there are two sides. So you have something to contribute to it, but the other has a lot to offer, and the user context, which is critical in climate services, is almost always on the other side. What is also interesting is that there was a reflection at that point of the fact that by engaging in this dialogue with the user and engaging seriously in that dialogue, well, the result you end up having may be very different from what you expected at the onset. So maintaining a significant level of flexibility was an important aspect. I mean, these are all published and available online, so you can find more there if you're interested in those. There was following some of those projects, there was the publication of a roadmap for climate services into 2015, and then there were I put here a few projects that I happen to have some closer interaction with related to climate services, including MedGold. But there was, I think there is very little doubt that the Commission put a lot of effort towards climate services, and there was a very significant increase in the number of projects related to climate services for agriculture, for energy, for insurance, even research project on climate services as per se. So what is the market for climate services? What model works? If you look at Marco and UMax or Clara, they were all almost a meta climate service project. There is one approach, and I picked this slide from a very good seminar that Francisco Doblas Reyes gave at the CNWF last year, the annual seminar. Because there is this idea of going from the data to the users in steps. And one of the important points, and I think these are quite useful as a simple paradigm for services, but there are a few caveats here. One is that it's not linear. It's not just a three-step jumps. There is a very significant number of additional steps. So this idea of the intermediaries, I think, is almost a continuum of intermediaries. You provide services to service provider, who provides services to other service provider, and so on and so forth. And at times it's difficult to get information on the whole chain. The other point that is very important here is the fact that it's not a just one-way street. So going from the data to the decision making, but there is a way back. There is a feedback loop that is at least as important. And I think Miguel was mentioning the evaluation and quality control framework that we have within the C3S program, and this is one of the ways in which we can feedback information from the users back to the design of the program. So this is one of the added value for me of climate services. And going back for a minute about narrative and storytelling, I think there's been a lot of development in recent years on this transformation, because it's really not just about the data alone. If you look at the UKCP 2018 and how they interact with the users, or if you look at what the Dutch have done with the KNMI 14 scenarios, or more recently the Swiss with the climate scenario for Switzerland, especially this last one, basically contain very little data as such, and a lot of information. Well, you can get to the data if you want, but it contains really simple storylines. So what you see on the right is the final report, and there are these 4 fictional characters, and each one has a problem and an issue. So the one bottom right, I think, is Hans, the kid who tried to go sliding on the snow in a green field because the snow is gone. And this makes a lot, account a lot for that translation between data to user. So I think the landscape has changed between the early 2000s and now quite significantly, and all these experiences are very, very important. Nevertheless, data is still there, and data is an issue. So if you want, largely what I discussed so far is a bit of a historical view on climate services and the importance of the users in climate services. But there is also another side of the story, and is the fact that if you want this informed decision to happen, you need to provide the underpinning data in a way that is easy to manipulate, in a way that characterize the overall uncertainty well, that is clear, and so on and so forth. And this is challenging, and it's a challenge that is increasing with time, if not else because the size of the data is increasing with time. So this is not, what you see here is not just the climate data. This is the archive of ECNWF weather prediction, but it's just a bit like the Moore's law in action, in the sense that the amount of data that we can store is going up with time. Well, the amount of data that we can generate actually is going up with time significantly. And so we need to find ways of storing it. And it's quite staggering. And it's not just the sheer amount of data. If you look at climate projection rather than weather predictions, then this is the set of model intercomparison projects that are part of the next assessment report. Well, if you want, the CMIP 6 of the climate intercomparison program. And it's just a wild forest of different MIPs that is difficult to navigate, even for those people who are more used to this kind of information. So there is a central set of simulation known as DEC, which is the basic one, but there are many others. And for instance, the high resolution MIP can be very relevant for some application, as it can be the decadal prediction, and so on and so forth. So it's becoming very difficult to handle all of this if in the absence of a dedicated infrastructure and system. And this is a bit what we are trying to do within Copernicus Climate Change Service. So what you see in this simple infographic is a general description of the center of the entire program, the so-called climate data store. So on the one hand, on the right-hand side, you see this petabyte, and we really talk about petabyte of data that are distributed on servers all over the world. And on the other side of this diagram, you have the few kilobytes of information that are required by decision making to make their decision. And a lot of what we try to do with the climate data store is transform efficiently and traceably in a reliable way the data that is on the right-hand side in the information that is on the left-hand side. So we do it by mapping all this data into a common data model and develop a set of tools that runs on the cloud that allows the manipulation of this data in an efficient way. So I think we can rapidly skip this one, because what is really interesting is to see what is there. So on the climate data store now, so there are observation, climate data record, there are ECVs, we were mentioning ECVs before, there are reanalysis, seasonal prediction, climate projection, sectoral impact indicators, and so on and so forth. So it's probably one of the few, if not the only place, where you can find all these sorts of relevant climate data in the same at the same location, and basically as much as possible interoperable with one another. As of a few days ago, we had slightly more than 40,000 user registered, and we deliver roughly 50 terabytes of data per day, with 65 data set available in the catalog. And as I mentioned, these are ranging on all sorts of things, from seasonal prediction to climate projection. But the effort is to maintain a simplicity and a coherence in the way the data is provided. So a description that describes the data in simple terms, a way of downloading the data that is efficient, and an EQC tab. So again, Miguel mentioned the evaluation quality assurance aspect of the program. This is yet not visible, so it's probably one of the biggest part of the entire program in terms of investment from our side, and is still largely invisible. But from a couple of weeks from now, this will become visible, and you will be able to find information variable, very variable, about the quality of what you're seeing. And quality is one of these difficult concepts, because it's difficult to define quality in absolute terms. But what you can do is to provide quality information alongside the data that will allow users to make their decision on the suitability of a specific data set for a specific purpose. I mean, I don't want to go through all the examples, all the data sources we have, but I thought this was quite interesting also because it's very new and is the back extension of ERA 5. So these are reanalyses, so describing the past weather anytime, any place on the planet with an hour resolution back to 79 up until very recently, and now extending back to 1950. So the 1950 to 1979 are not yet available, but will become available very soon. And as this plot shows, we have the data, the runs are finished, and we're just consolidating the data. And going back in times means is one of the ways in which we add values for the users. So whether you work in insurance or in agriculture, actually having a longer time series means having a larger data set that you can use to train your own model and to check how robust or how good it is. As I mentioned, the data is retrievable either through a web interface or through an API that is quite reasonably well documented, let's say. So you don't need to go on the website once you have accepted the terms and conditions once. You can just retrieve it automatically, the data set, and have it in your inbox. But still, this still somehow less optimal, because it requires you downloading large volume of data. And if you look at ERA 5, so the last slide I was showing, this is in the order of 6 petabytes, so a huge volume. You don't want to download 6 petabytes. And that was very much the idea of having basically cloud infrastructure that allows user to manipulate the data and transform it and subsetting into something that is more manageable. So there is this computer and computer all look the same, like black boxes. So it doesn't, I mean, the picture, I think it is quite a good picture, but nevertheless, it's not particularly telling. The numbers on the side of the picture tells a bit more of a story. So this has some capability to process data and has a decent size of this space, which is partially used as cache and partly as a way of handling, manipulating data. But it's not a supercomputer, so you cannot expect to really do very severe calculation, but you can do things. So one example of one of the things we have done was a bias adjusted version of ERA 5 to so that it could be used for impact studies. So if you look at the EasyMIP, so these are the MIP, the Model Intercomparison project related to impact, they are often driving crop models or hydrological models with past data as a benchmark, as a baseline simulation for the future run, or they use baseline runs as a way of bias adjusting future runs. And to do that, they want to have a reliable data source. This is what we have done within the Climate Data Store, and is a version similar to the WFD EI, so the watch forcing data, if you are familiar with it. And we've repeated the exercise with ERA 5. So if you are interested, you can retrieve the data. But more importantly, and this is the entire point, the algorithm that we use to generate the data is available on the Climate Data Store. So you can reuse and manipulate or regenerate the data at your leisure without the need of downloading it. One of the criticism that we have seen over the last few years was that the documentation for manipulating the data wasn't sufficiently good. And we are working hard to improve that. So there is much enhanced CDS toolbox documentation, and there is a gallery of applications. You can pick the plot you like and redeploy the code behind and regenerate the plot, or modifying or add on top. But these are, if you want, going back to my description of the chain between users and decision makers, we are sort of providing tools and data feeding the very top of the chain. So feeding the first step, feeding those intermediaries who are still quite close to the data. And we believe this is an important target because act as a multiplier. By providing this data at the top of the food chain with the right resources and the right data, there is the ambition of trickling down the benefit of the use of this data farther and reach a much broader audiences. Now you have a few slides before wrapping it up, because I know I don't want to overrun. Just a few slides highlighting some of the future developments that may be interesting for you. The first one is to look at the decadal prediction. So when I mentioned the portfolio of data set we have in the climate data store, there was clearly a gap, and that gap was represented by the decadal prediction. So those beyond 1 year and typically less than 10, with probably a very interesting interval around 1 to 3 years ahead. It's still very, very new, and we are still learning how to use them. Nevertheless, there is evidence suggesting that for some hazard, especially, the decadal prediction provide more value than the one you would be able to obtain from other sources. So either assuming the existing trend or assuming current risks. The second important development is about attribution of extreme events, and this is mostly related to the press, to the media, in the sense that every time there is an extreme event, we are always asked whether this is due to climate change, attributed to climate change, and so on. So developing a mechanism or a protocol for triggering an attribution and communicating attribution information is becoming important. Other important developments has to do with the CO2 service. I mean, even now with the COVID situation, everyone is asking what is the impact of COVID on the global emission of greenhouse gases. And while we can have some generic information on the concentration of greenhouse gases, when you get at emission level, and especially if you want to have emissions at a high resolution, so that to pinpoint or to provide information at country level or regional level, we don't yet have the mechanism to do it. So the idea is to develop a service able to provide information about emission, CO2 emission at a fairly high resolution. And this is there's a roadmap also associated with a new set of satellite being launched in the coming year that should lead to a system running in time for the second global stocktake. So let me just try to wrap up this quite diverse talk here. So one of the questions is really about this chain going from the data to the users. And one of the questions for us is, how far do we go? So we can go as we have done in the past, all the way down and provide a service, or we can decide to stay one step behind and just provide infrastructure that allows the development of services downstream of us. And that's a model that we are likely to follow in the future, so that project like MedGold can thrive. And even after the end of MedGold, companies or local administration or public governments can take advantage of some of what has been done to generate and maintain services in the long run. So it's really the concept of an evolving subsidiarity. We don't want to interfere with the people who want, or who can, not only want, who can develop useful service downstream. We want to empower them, and that's important. And it is a good time to have this discussion because we are at the end of our first delegation agreement, and we are now writing our next delegation agreement for the next 6 years. There are a number of uncertainties. We don't know the budget. We don't know exactly what will be in. We don't know exactly how this will interact with the large legislation that is being drafted at European level, such as the Green Deal and the climate law and the like. But we are working on it. And so input, ideas, suggestions are always welcome, and we will be happy to hear from you either directly or through the many channels we have for engaging with the community of users and communities of providers and scientists in Europe. So I think I can wrap up here. Thank you very much for your attention.
Thanks, Carlo, for the very informative and engaging presentation. I think we have time for one question. If anybody wants to ask a question, please go ahead. Otherwise, we move to the next presentation. That will be a presentation by Antonio Graça, also GRAP. And while Antonio puts up his own slides, I just want to add a few words about GRAP. That is the largest family-owned winery in Europe, and they grow grapes across continents, and they sell wines in like 120 countries around the globe. So they're kind of a global company. And Antonio in particular is head of research there. So it's a wine company with a research department, which I would like to bring your attention to. And in my experience, I mean, it's the first time I see it. So I don't think it's so common. Maybe Antonio wants to comment about that, but please, Antonio, address our online audience, and thanks for joining us and for contributing to our Living Lab.
Okay, good morning. Can you hear me? Can you hear me?
Yes.
Yes, I can hear you. I hope the rest can do it also.
Okay. Okay, sorry, I was just checking. Good morning, everybody. It's a very nice pleasure for me to be here today with all of you. Coming from an agro-food business, I have been working and cooperating on to climate projects and climate services for a while, and this specific project Met Gold has been very rewarding in terms of the advancement we have been seeing. So it's great to have such an audience here today with so many backgrounds coming from so many places. Commenting on what Luigi just said, yes, it's not usual to have wine companies with a research department. I have counted about 8 wine companies in the whole of the European Union that have a fully structured research department like we do. So that's not a lot when you consider that there are more than 30,000 companies in the European Union alone. Also correcting, just a small correction, we are not the largest family-owned wine company in Europe. We are the largest in Portugal and one of the largest in the Iberian Peninsula. The wine sector has a great number of family-owned companies, which is, I believe, part of what the sector is itself. So, just a very short comment about myself and what I do. Luigi, can you please confirm I have 15 minutes, right?
Yes, Antonio.
Okay, just make that sure. So I have my background is on the science of wine. I have a master's degree in enology, and I worked for the first half of my professional life, that was up to about 17 years ago, as a winemaker here in Portugal. And after that, I was asked to create the research department in my company, and I have been managing that ever since. Okay, so moving forward, and I believe you are watching my screen. So wine is this interesting product coming from the fruit of the grapevine, from the grapes. Grapevines are pretty much spread all over the world, even though there are some limits, some geographical, climatic limits to its spread, mostly when you move towards the poles. But roughly, you can say that the grapevine can thrive anywhere between latitude 50 north and 50 south. However, you cannot produce good quality wine everywhere within those parallels. There are two bands of ideal conditions that may shift upwards or downwards according to local or regional conditions, mostly influenced by the presence of oceans or continental masses. But as a rule of thumb, you can produce wine with good quality between the parallel 30 and the parallel 50 on both hemispheres. So an interesting thing about the grapevine is that it uses sunlight to capture carbon dioxide from the atmosphere, and together with water it brings from the soil to create energy reserves for the plant. That's what you see on this schematic. The growth cycle of the grapevine that actually repeats itself every year is separated in two halves. There is a first half where the plant grows vegetatively, so that the reserves it produces from photosynthesis are being stored in the lignified part of the trunk, in the leaves, and in the green shoots that grow on that ear. And then after a moment that we call veraison, that is when the fruits, the grapes, start to get colored, the reserves start to be directed towards the berries instead of the vegetative parts. Sunlight is really important in this, not just because it feeds on the photosynthesis process, but also because of the temperature it supplies to all the physiological processes. At the same time, the flow of water in the plant has got to do with a lot more than just converting CO2 into reserves, mostly sugary reserves, under the form of cellulose during vegetative growth, and under the form of glucose and fructose during the period of grape ripening. But on top of that, the water flow is also used in great quantities to keep the temperature of the tissues at manageable values. So evapotranspiration through the plant plays a major role in maintaining the capacity of the grapevine to adapt to different situations and to keep thriving and under the adequate conditions to produce grapes with all the necessary requirements to make viable fruit, but also fruit that can be used ideally to produce wine with characteristics humans find pleasant. So an issue that has got to do with water and water flow in and around the plant is the issue of parasite development, in this case fungal parasite development. When you have high humidity levels, or when you have high values of rainfall occurring during short periods, you get conditions for fungal development to occur, and these parasites that destroy the tissues of the plant make for a really important economic impact into the activity of viticulture. What you see in these two pictures side by side on the left is a totally sane bunch that has been just fertilized and has set the fruit. You can see the small green berries, all perfectly formed. While on the right side, you see a bunch of inflorescences that has been attacked by one of the most prevalent fungal parasites we find across the world, commonly known as downy mildew, and caused by a pathogen named Plasmopara viticulum. So what this causes is a significant loss in production at harvest time. The affected berries will just dry out and will not grow at all. They will be destroyed. And in years with severe pressure for this disease, we can see whole vineyards losing more than half of their crop, and some extreme years going as high as 80%, 90%, sometimes even the totality of the crop may be lost in some specific places with severe attacks. So this is one of the main concerns for the grape farmer, the grape grower, to make sure that he keeps this disease at bay. So for the problem I am bringing you today, I propose to focus in a wine region in Portugal, in northeast Portugal, the valley of Riva Douro, that has been known as a source of high quality wines for more than 400 years now. Actually, it has been the first wine appellation to be defined and regulated in the world. And in this specific case, I am proposing you focus in a specific point that where you can see the coordinates, which is a vineyard in this area. So this is the vineyard. These are 70 hectares of top quality grade for wine. As you can see, is a specific situation of mountain viticulture. Vineyards are grown in slopes, and different methods have been developed along the time in order to systematize vineyards here. So in this area, in mid-slope to the right side, you see the most traditional system using stone walls to support the terraces, and more to the left side down you see other areas with earth-supported terraces, and then also what we call the vertical vineyard system, which is the most recent that has been introduced in the region. So the problem is, and considering climate services and specifically this climate service of seasonal forecasts, when and how to decide for a vineyard manager to use either the historical climatology or an available seasonal forecast to calculate the need he has to stock for plant protection products, so products that he will need to use to protect his vineyard if a condition with high rainfall, high humidity will occur. For this, I have collected a number of data that will be important to take into consideration. So you have the pricing of protection products as a function of how long in advance you order them. So 2 weeks, 3 months, or 6 months advance. You have also an average value of the quantity of protection product you have to use per hectare of vineyard when the spring rainfall is above 200 millimeters or when it is below 100 millimeters. You also have an average yield for years with those two specific conditions of spring rainfall, and you have the value, the average value of a kilo of grapes, good enough for winemaking. Some considerations should be taken into account when looking into this problem. Let's assume that you will always have protection products available. That's not really the situation. Sometimes when you have an event that drives demand and all farmers jump to the local stores, you have often out of stock situations where even if you could buy them, you just don't find them. However, for the sake of this problem and to make this a little bit less complex, let's assume you can get as much as you need. You also should assume that the validity of these products will be 1 year. That is, if you buy too much and you cannot use them this year, they won't be usable the following year. Therefore, the capital that you have put onto that product fraction will be lost. Also, do not forget that you only have one harvest every year. That's something most people know, but some other people who do not contact daily or yearly with this culture may not be aware of that. And also in some places, you can have more than one harvest a year in tropical situations mostly. However, in this place, you can only have one. Spring rainfall is the sum of daily rainfall between April 21st and June 21st. This is for the Northern Hemisphere, which is where we are. And to make it also less complex, let's assume that in this case, the only driver for the use of protection products is rainfall, even if we know that relative humidity, solar radiation, and wind also do play a role. But for this problem and to make it approachable in the short time of this living lab, let's assume the driver will be rainfall, and in real life, it still is the main driver. So I hope that this presentation was clear enough. I'll still be here for some more time until the end of this session. And I hope this is a good experience for you and that you have a good learning. Thank you.
Thanks, Antonio. Thanks again. And now we move to the next presentation. We're gonna be hosting Chiara Monotti from Barilla, and I just want to remind you that these three problems that you're gonna see presented today in this session, the different groups will have to make a decision during the course of the week which of the problems they will be addressing for the rest of the Living Lab. So keep that in mind while listening and watching the presentation, that the different groups will have to make up their minds and decide on one single problem that they want to address and work as a group for the rest of the Living Lab. So I would like to welcome Chiara. that I see on the screen. And buongiorno, Chiara, and welcome. And but she
Hello.
works for Barilla, and they are one of our industrial partners in the Med Gold project. Barilla is a brand that is immediately associated with pasta across the world. So there's not much that I can say beyond the fact that they're the largest pasta producers in the world. So please go ahead, Chiara, and address our online audience. Thanks again.
Hello, good morning, everyone. Can you all hear me? Hi.
Yes.
I'm sorry that I think that there are some technical problems here. I'm trying to share my screen, but anyway, even the presentation that I see here is okay if it doesn't work. First of all, welcome to this Living Lab experience. It is a new experience also for us in this European project. And I am Chiara. I work in the market intelligence unit at Barilla, which means I work in the research sector dealing with the raw materials, the agricultural raw materials that we buy in Barilla. Barilla is an Italian food company born in 1877, and it is a family company. It is an international company because it is present in many countries in the world. It exports in over 100 countries, and it has 28 production sites, 14 of which in Italy and 14 abroad. And it is a company which is mainly known for pasta products, but also for bakery, in particular in Italy and also in France, in Russia, and in other countries, and for sauces and ready meals. It has a turnover of roughly 3.5 billion euros, and this is mainly built in Italy for a 46%, and mainly in the categories of pasta and sauces and ready meals. Now, the problem that I am addressing here with you today is regarding the durum wheat, which is the main raw material with which pasta is built, because pasta is just made of durum wheat, which is grinded, and water. Durum wheat is purchased from Barilla in many countries in the world, but mainly according to where the production sites are, the most of the durum wheat is purchased in that country. So, for example, in Italy, for all the production sites that we have in Italy, Barilla purchases an 84% from the local market. And most of it, like 70% of all the durum wheat which is purchased in Italy, is under cultivation contracts. What does this mean? It means that Barilla signs contracts directly with elevators and with organizations of producers like cooperatives in order to have the durum wheat cultivated in a specific way with specific quality parameters to allow pasta production of the whole quality profile in Italy. So for this, the main regions from which durum wheat is purchased are in the northern part of Italy, a region called Emilia-Romagna, and also from the southern part of Italy, other places like, for example, the Apulia region, which is one of the main and the most important for durum wheat production in Italy. Now here I'm addressing the case for the Emilia-Romagna region, where also the headquarters of Barilla are in Parma. This is also because inside Emilia-Romagna there are very important places, as you can see here. Thank you for sharing this screen. You can see here the Emilia-Romagna region, which is in the northern part of Italy, is the one highlighted in green, let's say. And here we also have some specific cultivation contracts under something that we call a supply chain contracts. That is 3-year contracts that we have with producers, which is a quite high-level type of contracting that we have started a few years ago, and that is continuing very well with the region Emilia-Romagna in particular. and which allows Barilla to have not only the specific cultivation contracts, but also to ask farmers to follow some important sustainability, let's say, guidelines for the production of durum wheat. And this is why I wanted to choose this region for you today. Our main topic basically will be to ask you basically the situation of the climate scenario at 2050 in Emilia-Romagna and how this would affect durum wheat. That is, we provide you also with some data that might be useful for you regarding the durum wheat data, in particular the fact that in Emilia-Romagna the cultivated area is of 60,000 hectares for 300,000 tons of production. And inside this big production, we also buy as a supply chain contracts 360,000 tons in 3 years, starting from 2019. And there are also several maps from Emilia-Romagna, also regarding the land use, climatic tables, and also showing you the orography and the phenological curves, which we can provide you. So just to have you informed about this crop in particular, this annual crop. Consider that in Emilia-Romagna, this crop is sold in mid-October, let's say, and is harvested at mid-June. So this is the cycle of durum wheat in Emilia-Romagna. There is also a phenological curve which will show you inside these documentations that we will provide you the periods, the phenological phases of the crop, how it grows, just to have in mind how this works. But basically, I believe that for your case study, the situation at 2050, let's say in a very long term from now, you might also need a few more information regarding also the historical data for the climatic situation of temperatures and humidity, as well as rains and so on. So basically, this is the main information that we will for now provide you for the case study. We will also provide you with a few articles that might be useful for you with the public literature regarding the phenological models, how they are built, also with some examples that might help you also to answer this research question. And then, of course, not only today, but I will be always following you in the next sessions, and also I will always be at your needs whenever, even by email or with short calls if something is unclear, or if you would like to have some more information on this case. Thank you.
Thanks, Chiara. Thank you very much. And now we move to the next presentation. I just want to remind everybody that if you want to come up with a quick question, that's fine. But in general, you will have time to ask questions specifically to the problem holders during the course of the week for the problem holder you choose in the group. So there will be plenty of time to interact with them. But if you have a quick question today, it's fine also. And I would like to ask Ilaria Danesi to present her problem for coffee. And again, Danesi is a company that has been producing coffee for a long time, for more than a century, as far as I know, and it's very popular brand here in Italy. It's one that I like in particular. So thanks, Ilaria, for joining us, and please address our online audience. Thanks. switch on your microphone, please, because I personally unable to hear you.
Can you hear me now?
Yeah.
Okay. Thank you. Thank you, Luigi. Hi, everybody, and thanks for inviting me. This is a very new experience for me as well and for us. And as Luigi introduced us, we are a small medium company operating in the coffee industry since many years. My grandfather started the activity in 1905, and it's a completely family business, and me and my sisters are at 4th generation running this company. And specifically in the organization of the company, I am in charge in selecting and buying the raw materials from coffee producing countries all around the world. And as you know very well, coffee is not produced in Italy, but it is produced is an intertropical crop produced in more than 50 countries on the equatorial intertropical belt, and it requires very specific climatic and soil condition to be grown. I wanted to show my presentation, so I'm going to share the screen. Can you see the screen?
Not yet.
It's coming.
Now,
yeah.
now yes. Great. Thank you.
Okay. Can you see the presentation?
Yeah. If you put it in presentation mode, like full screen, it probably will show slightly larger. But that's fine, I think, anyway.
I am trying to put the screen on the other. No. Okay, I am going to present this, if it's okay for you, in order not to waste time.
Yeah, no.
Yeah, please go ahead.
No problem.
Okay, as far as I am concerned, just two seconds to present myself, and my academical background is regarding the economic sector. I graduated in economy in Rome, and in coffee I started to develop my own experience, especially in going to the countries where coffee is produced, so with by field visit, and then participating in several international projects with Italian cooperation, and doing a PhD research at the University of Trieste. At that time, I developed a lot of information on coffee and how this plant grown and develops, doing this thesis regarding the climate change and coffee cultivation in Uganda. That is a country that produces mostly Robusta. These three, the most cultivated species of coffee in the world are of two species that are Arabica, Coffea arabica, and Coffea canephora. This is a little bush, a little trees that can spontaneously grow even up to 30 meters, but in order to be cultivated from an economic point of view, the farmers leave the plant growing up to 3 meters. As for many other agricultural products, the coffee, the climate change is one of the main factors influencing the price trend of coffee that is traded in the main international market of United States and Europe. One of the main factors influencing the price of the coffee is climate change, because climate change influence and negatively affect the cost of inputs. Without an adequate and proper management of soil nutrition and supply of fertilizer of the plant, in order to give to the plant the capability to sustain an optimal development of the fruits, the impact on yielding and even on quality could be severe. Thus, at the last stage, can have a negative impact on price of coffee, of course. So, directly presenting the objective of study, in which we are interested in, is to taking into consideration the climate variability and coffee cultivation in a specific area that we have selected, on which we are interested, to identify potential costs to coffee farmers from the need of greater use of inputs. So, based on climatic fluctuations of temperature and precipitations in the area under investigation throughout the crop cycle development and in certain development stages of the crop, you've been asked to specify whether the variations will lead to a greater use of inputs, fertilizers and pesticides. In order for us to understand if climate change will lead to farmers to use a greater use of inputs and thus to an increase of cost of production. Of course, without taking into consideration a lot of other variables that can influence the price of the coffee. So it's very important to assess, especially the impact of climate change on distribution of inputs during a certain stage of crop development. The phenology of coffee it takes is a perennial crop coffee, but we can focus the analysis on just the crop development stage of flowering and fruiting, when the plant need certain and specific conditions of temperatures and rainfall and amount. We will see this later on. And at the end, this data that can arise from this study and this analysis can bring also to implement an easy to use method from farmers in order to help them to use this seasonal forecast to set up or adequately improve or adjust their management strategy to maintain the balance in terms of nutritional and phytosanitary point of view of the plants in order to adapt and alleviating the deleterious effects of climate change. So this is the problem. As far as concern the location of the study, we have decided to ask you to focus the analysis on Colombia, because Colombia is one of the worst coffee producing country in the world. The most important coffee producer in the world are Brazil, Vietnam, Colombia, and Indonesia. Colombia is the second world's largest coffee that produced Arabica beans after Brazil, but Colombia is the first countries all over the world that produced washed Arabica beans that is considered the coffee of a higher quality. Among the two species of coffee that are most cultivated all around the world, Arabica is the species that produces fruit of a higher quality. And depending on the process and on the conditions where the coffee is grown, it produced a fruit of a good quality or not, of course. You can see in this map that the coffee is very important for the Colombian economy. Along the 3,000 kilometers of valley in the Andes highlands, coffee is grown by coffee farmers. In Colombia, the family that produced and growing coffee are 540,000. So in Colombia exists an economy related to coffee of small farms producers. According to the latest data from Coffee Federation, the National Coffee Grower Federation in Colombia, the coffee planted area is around of 900,000 of hectares, out of which 780,000 could be considered as technified crop. That means that this area is cultivated with improved varieties like rust-resistant varieties. Rust is a fungus that can produce this foliage disease, and so there are a lot of study by scientists improving these varieties that can be resistant to this pest and disease, as we will see later, that are growing, occurring due to climate change, and technified crop also because the plants are younger than 12 years old. That is the period, the most productive period for a coffee plant is on average between 10 and 15 years, and with a dense plantation. The coffee is very important for the Colombian economy since 2.2 million people, that is 25% of rural population, depend on coffee farmer. And it's the 8% of total exports depend on coffee, and the coffee contribute for 12% of the gross domestic agricultural product in Colombia. So it's an agricultural product fundamental for this country. All this economy is based on a family farms. As you can see, from this slide, the composition of the coffee growers by coffee area. In Colombia, we have 95% of smallholders that cultivate less than 5 hectares, and out of which 60% of these smallholders have a planted area of less than 1 hectare, and only 5% are cultivated more than 20 hectares and could be considered as larger farmers. So we decided to focus the analysis on some departments where coffee is cultivated, as you see in the slide before. The coffee is grown in 600 coffee municipalities, and there are 14 coffee regions in which coffee is growing along the Andean mountainous range. The study should be focused just on these 2 departments of Cauca and Tolima. Another specification that should be done is that due to the great diversity of climate and microclimate and the diversity of topography that characterize this country, Colombia could be considered the land of diversity. And this means that Colombia is allowed to produce fresh coffee all over the year. And so it's not we cannot say that in Colombia there is a specific harvesting time as in other countries that produce coffee all over the world. But there are 2 main harvesting seasons depending on the region where coffee is cultivated. But we can say that there are 2 main harvesting seasons that goes one from October to December and another one from March to June. So also with the aim to facilitate the study, we selected, and also because we are interested in the coffee that is produced by these 2 departments of Cauca and Tolima. Consider that now Huila, Tolima and Antioquia contribute for the 46% of coffee produced in Colombia, and so Tolima is for sure an interesting department on which to focus on the analysis, and we will take into consideration just the harvesting season from March to June in order to facilitate the study that coincide with the main harvesting season of the other department, Cauca, where the main crop go through March, from March through June, the same period of South Tolima. And since, as we were mentioning before, the majority of smallholders are located at the medium altitude, that means coffee grown from 1,200 up to 1,600 meters above sea level from these smallholders that are holding less than 5 hectares. The study should consider this elevation. Just a note on this condition, as because Arabica beans cultivated over 1,200 meters above sea level develop a higher quality, also because the quality is related to a perfect combination between altitude and latitude, because at higher elevation the solar radiation is more intense, and there is a more difference between temperature in the night and during the day, and this allows the beans inside the coffee cherries to develop and to mature more slowly and more gradually. And so from these beans the quality is higher in terms of acidity, especially on acidity, that for coffee is one of the main features when the quality of the cup should be considered. So the challenge for farmers, even though we can say that even though the effect exact of climate change can vary, as we have seen up to now, greatly between regions, it's a matter of fact that the challenge for farmers is this variation in temperature and precipitation patterns, which are becoming more and more difficult to predict. So, as you can see in this slide, the major factors influencing the coffee yield and quality are temperature, of course. We will focus on Arabica production, and for Arabica production, this kind of species prefer cooler temperature than Robusta production behind higher elevations. And for Arabica, the optimal mean temperature during the year should stay around in a range between 18 and 22 degrees Celsius. And for annual precipitation level, as an average, the plant prefer precipitation that goes around 1,600 and 1,800 millimeters per year. But it should be noticed that for the coffee plant in general, the annual rainfall and the duration of the dry season are the most important water-related parameters for the coffee plant. It means that coffee plant likes a period of drought, especially to induce the hormonal response for the plant to induce flowering. But if the dry season is prolonged, this could be the impact on yielding could be very, very severe, with the consequences of abortion or drying off the flower. And then another important parameters for coffee to grow and develop fruits is a constant and high relative humidity of the air that should be around 60% all around the year at least, and the solar radiation. So as I was mentioning before, the combination of altitude and latitude is very, very important. The coffee doesn't like a direct sunlight, but the perfect environment for the coffee is like the natural habits of coffee, that is an agroforestry system. The most suitable condition is an environment where it is a not too intense canopy, but a moderate canopy where sunlight can go through the canopy, but not expose the plant to a direct sunlight. in the equatorial intertropical belt where coffee is grown, many regions like Colombia, just like Colombia, are already experiencing higher temperatures and prolonged drought, and also some episodes, extreme events related to heavy rainfall. This kind of episode produce a very impact negatively the coffee crops, like disrupting pollination, limiting the growth of the plant, limiting to develop for the plants a right leaf to fruit ratio, limiting for the plant to make its photosynthetic activity in a proper manner and uptake the necessary nutrients from the soil in a right way. In the area under investigation in Colombia, I have searched for the last climate change related event that had a very important impact on coffee production in Colombia. In 2008 and 2009, El Niño produced a non-typical dry weather event in Colombia, triggering an increase of the occurrence of berry borer, that is one of the most serious pests for the coffee plant, and with the consequences that the farmers used less fertilizer, and this impact the yielding and the productivity of the coffee starting from 2009. Another event occurred from 2009 and in 2010, when where La Niña phenomenon produced above normal levels of rain, and also this one produced a decrease in the productivity. So these events are very important for coffee also because another effect is that they increase the occurrence of coffee pest and disease because of the high temperature, high relative humidity and precipitation. As I was mentioning, coffee berry borer and coffee leaf rust are the most costly pest and disease in the coffee, and especially the period of prolonged drought or the delayed rainy season let the coffee berry borer to occur and to attack the fruit of the coffee. Here there is some example where in 2009 the coffee berry borer infestation reached the 7% in terms of percentage, and from the last data of the Coffee Growers Federation in April 2020, the rate of infestation was 6.2%. Consider that the optimal rate that explain that for infestation of berry borer should be less than 2%. Here there is another example of the rate of infestation of coffee leaf rust. That is a fungus that produces a foliage disease that is very high, especially in the department that we have chosen. So having said all of these, it will be very important for farmers to have some seasonal forecast to be used in a very easy way in order to assess new fertilizer and pesticides management in order to decrease the losses in yielding, and also using this data in a specific crop stage where the crop is development, and maybe one of the most important effort that we can do is to transfer this knowledge in a very easy way, maybe implementing or developing an easy to use tool from farmers, especially to the million of remote farmers that produce coffee in the mountain of Colombia, in a way that they can, these farmers can use, can adapt, and can understand this data in a very simple way, in a way that can be useful for their coffee plantation. Sorry for taking so long time. Thank you.
Thank you, Ilaria. Very, very detailed, informative presentation. And